Hello. Recursive function to print the factors of a number. Now when it is a factor of a number, the printing of the factor takes place only if the condition of the factor becomes true. Now, there are a lot of numbers which are tested, but not all of them are printed because when it is a factor, there is a range, the lower limit being 1 and the upper limit being itself. The no number can have a factor which is bigger than itself. Therefore, the range is set. That means from one number 1 to itself is the test range. So what we do here is we are going to activate the super function or the level 1 of the recursive function with two numbers, assuming them to be 48 for num and f to be 1. Now, if I take this assumption, then I can flow in one way. There are different ways of doing it. The other ways are also possible. Let me test. Now, when the first number is tested, obviously, for 1 it will become true and hence 1 will get printed. So, this is the first one. Now, you see, the work will stop when f will cross num. That means if f is more than num, then terminate. That means go back. Otherwise, go on opening up the folds. How to open up the folds? Increase f by 1 and call the method once again. That means the super function makes a call to the sub function and see the value of f is changing 1 by 1. Now, whatever is the value of num, the mod of f will decide whether that should get printed or not. So in this way, one by one, all the numbers in the range are getting tested. What is happening towards the end? At the end, when f reaches the equality of num, then again the condition becomes true. And when f crosses num, that means when f becomes 49 in this case, what happens is the base case becomes true. And that causes the final fold to wind up. The final fold closes, comes back to its previous, that comes back to its previous, that comes back to its previous. In this way, all the folds wind up. Look at this example code, the program here also. Now, what I can do for you is I can show you the work with, I'm showing this work with 48 for you now. And I have got an upgradation of this as well for you. Okay, because you can even say that the entire so many folds are unnecessarily opened for the upper half, that means more than half of the number. If the number is 100, then after 50, I don't think any number needs to be tested for 100 to become true. Between 51 and 99, there will be no factor. So, I would like to show you one modification upon which you will decide how the work is getting shorter as well. Okay. Look into the change. You see, the value this time chosen is 100. And against 100, I have not taken the factor limit more than the half. That means the testing is not going to take place when f is becoming more than half. So when f in this rounds become 51, till 50, it is checking all of them one by one. When it becomes 51, the method is going to terminate because 51 is not needed. Up to 99, it is not needed to check. So what it's going to do is, there's a guarantee of the number itself to be a factor. So just look into the output. Before it starts winding up, it says, and also take whatever is in num as a factor. You can even see what will happen if I choose a prime number. Okay, just wait for me to show you that. Check out the values printed and verify how is the code printing these numbers. Okay, now what I'll show you here is, first of all, the printing is taking place for all the values of f unconditionally. Whatever is f is getting printed. So f is getting printed as 1, and I've printed a tab here only to show you that if it is a factor, then it will print it separately once again. So f is a factor, 1 is a factor, then 2 is taken, 3, 4, 5, 6. In this way, it is taking up to 9. Why? Because I have stopped the work but it is printing 17 before it is closing up. Okay?